All right. So I want to welcome Jeff Henkels, who's a product manager at Qualcomm, responsible for incubating corporate R&D inventions for commercialization. He's currently the R&D business lead for Qualcomm's ultra-low power computer vision glance program. And then in the middle, we have Wade Shen, who joined DARPA in 2014 as a program manager. His research interests include machine learning, machine translation, speech recognition, data analytics for better human-computer interaction. He came from MIT Lincoln Labs, where he was associate group director for human language technology. He was founder and CTO of Vocentric, and he has degrees from Maryland and Berkeley. And then Zach Shelby is a technology leader, investor, and thought leader in the IoT space. He's currently VP of Developers for the IoT Services Group of ARM. He co-founded Sensinode, where he was CEO and CTO before its acquisition by ARM. And he's also deeply involved in Microbit, which is working on making every child an inventor. So a very broad view of sort of the implications of this technology on a global and sociological basis. But we're really interested kind of in the question here of ecosystem and all of the enabling factors, not just technical, but also institutional, that are going to be important to bringing tinyML into the mainstream. And one of the things to ask is, what are the most relevant, and maybe even more illuminating, the least relevant pieces of the larger ML structure, the larger ML environment, to the success of tinyML? What is it that we can focus on in leveraging the broader ecosystem? And what is it that we shouldn't, expect to leverage? How do you see that may play out? Go ahead, Zach.
So I think training is a huge problem, and it's just going to get harder in IoT, right? We're dealing with new classes of sensors that we just have no clue where to start when it comes to training and labeling. So I think luckily, a lot of the training infrastructure that I'm seeing is reusable for that. We've got to get better at figuring out how to collect and manage that sensor interface. I think that's the biggest reuse, in addition to frameworks, right? Because when we work with developers, they're going to want to have easily understandable, documented frameworks. I think frameworks are going to have a place to play in tinyML, just as they do today.
Yeah.
So
it's a sharing economy.
Yeah, I totally agree. When I had students at MIT that were starting to build deep learning systems in 2006, the amount of effort they spent in terms of software engineering, trying to figure out how to make use of these GPU-like things in order to actually build practical networks for any real-size applications. It was incredibly hard, incredibly difficult, and the advent of really good frameworks has made it possible for us to explore the space of possible models, to do optimization of these models in a really revolutionary way. And I think Kurt sort of pointed out that what's coming next is ways to do that optimization even better, right? Through AutoML, through AutoETL, through a whole variety of automated processes for optimization that are end-to-end. And at some point, we need to think about how we do those kinds of optimizations in power-aware ways, right? In energy-aware ways. And if we can do those kinds of things, if we can translate AutoML and everything that we're doing to optimize into ways that we can do joint optimization of accuracy and power, I think there really is a potential for even a more revolutionary efficiency.
Thanks. I would say that, of course, there's a lot of room for innovation, a lot more room for innovation when it comes to algorithms and to training. There's so much that can be done there. There's some great examples. I have a few specific thoughts, but to me, the first generation of solutions is already out there. We see, we've heard already yesterday that there are great hardware solutions on the processing side already, sensor solutions, ML solutions, training solutions. Those things all already exist. It's just the first generation. There's a lot of room for improvement, a lot of specific things that can still be done, as you guys just mentioned. But it's there already. So if we're talking really about friction over the long term, what are the biggest points of friction? I guess I'll just beat a dead horse. You guys, we've been talking about what is the killer app. It's really at the top of the value chain when it comes to solutions and services. The killer apps are there. There's not just one killer app. There's many killer apps, and they're there right now, and the solutions are there right now. So it's just a matter of connecting the dots between the solutions and the pain points and the needs. There are plenty of pain points and needs. We just need the people that are in between, those intermediaries, don't know that these solutions are here. They're just emerging now. And so they need to learn about what's already out, these first generation of solutions today, and then figure out how they can apply them to these new pain points. To me, that's the biggest point of friction. That's the biggest opportunity that exists today.
Yeah. I mean, earlier this morning, we talked about, and there was complete consensus, I think, that we need better tools, better benchmarks, better standards. But where are they going to come from? And what are the relative responsibilities of Pete and Google to do it? The broader...
No pressure, Pete. No pressure.
Yes, just as an example. The broader open source community to drive it in that sort of organic fashion. The hardware platform makers who need to do it in order for their customers to buy the hardware, or the software and system makers who have to do it themselves because they can't get the product, the end solution out the door, or third-party commercial, tools makers. What's the role for at least those five constituencies or communities to do it? What's going to come from, the mothership taking care of us, the open source community, or is there a third-party tools opportunity here that's independent of those things, or will it be integrated fundamentally inside of the hardware makers or the solution makers?
So I think all these players have to come together. I think what we heard from ST earlier about the need to make this real for embedded developers is critical, right? We can't live in a bubble of data science and AI if we really want to make tinyML real. So I think everybody kind of has to align into the reality that there are real people making these products and systems, getting them to market. There are business decision makers that have to be convinced that this is reliable, safe, secure, right? Before they're going to deploy. We all have to come together to make that work. And I do think there's a role for third-party providers of all kinds of things, from training, DevOps, secure deployment, monitoring. So much that can be done in this space. I think the sky's the limit with new things. We'll see a lot of startups still to come here.
Yeah, I totally agree. And I think one of the key things that has happened is that a lot of this infrastructure is open. And it's open with standards at various points for people to be able to plug in and play, right? And so if we think about, how a number of these components are built on top of the NumPy ecosystem, SciPy ecosystem, and that basic abstraction of something that looks like an ND array being the underlying thing, it allows for all sorts of people to come in and play in the middle, in the replacement of these bits of infrastructure, and to do optimization on top of these infrastructures once we can figure out how to, fully support Onyx everywhere and model interchange formats like that. But because people are working towards these open standards, there are lots and lots of opportunities for people to come in, make better components for infrastructure specialization for different parts of the infrastructure for specific applications. And without that, I don't think that this could ever work, right? So I'm very optimistic that these things can actually happen. So, for instance, we fund a project called AutoTBM right now on optimization of inference through better compilation of these models for target platforms, right? That can't work without Onyx It can't work without all of the APIs associated with ND Array and the SciPy community. It's built on top of all of that infrastructure. And it is what makes that kind of innovation possible.
You guys took all my answers. Yeah, I mean, I would just echo the same thing. I mean, the opportunity for turnkey kind of hardware systems, hardware systems, that's important. Software, services and tools, plenty of opportunity there as we connect the dots between current solutions and needs. I guess I would just add one more thing. You use the word standards, and obviously, you're talking about technology standards. I would add benchmarking standards are important, right? There are all these disparate solutions that we see everywhere, and it's hard to know how to make sense of it until we've got performance type of standards to be able to compare things, benchmarks.
Yeah. Let me tiptoe into a controversial area. It's very much a sign of the times that every major country or geography has a strategic AI initiative that they are going to make big investments to ensure that their country and companies and researchers outshine all the others. As we pursue this, creation of ecosystem, how much is going to happen on a national basis or on an international basis? What's kind of the dynamic, or how do you think the dynamic's going to work out? I'm not trying to put you, Wade, on the spot, but clearly this is.
I feel like you're putting me right on the spot.
I'm putting you on the spot without really trying. Go ahead, Zach.
So I'm half Scandinavian, half American. So
Yeah.
I kind of have feet in both camps, and I do think you're going to see differences. You're going to see the U.S., unfortunately, because of the Valley's focus on copying each other, do a bunch of quantified health and pizza delivery and juice makers, and we'll AI all of that, right? About 100 times.
Because we always apply the latest technology to juice makers.
Yeah. So, which is going to be a great opportunity for Europe, because we're going to do an Industry 4.0. Germany's leading the way in that space. We're seeing tons of AR, IoT applications where ML can be applied, driven by Germany. Likewise, Asia is just amazing with applying new video-based technologies much faster than we can, partly because of a lack of regulation. Right. So their gap in regulation and privacy is giving an advantage to try new things, and some of which will be applied by us later, maybe in completely different applications. So I think every region has its advantages, and we're going to see collaboration. Open source, open research is going to be important for us to work together across the whole world.
Sorry,
I
Wade.
feel like this was directed at me, so just kidding. So I think there are a couple things. I think worrying about these kinds of strategic AI initiatives, fragmenting the ecosystem, is probably not going to happen. And the reason for this is beyond the size of governments is the size of industry. And the need for interoperability and internationalization of most of the business opportunities that we have. They are not strictly in any one given country. Our developer pools are not strictly within one given country, right? It's just not practical to think that you're going to create a nation-specific ecosystem and then try to defend it in that kind of sense. Also, it's just not practical in terms of reality, right? The reality is that, the math, the work that we do, right, often boils down to some very simple math. It is not hard for, while it is not hard for us to express that math in code, it is really, really very hard to optimize that math over and over and over again, which is why, when people here talk about BLAST, right, the fact is we're still built on top of 30 years of BLAST research. And what I think these strategic initiatives are best aimed to do is not to try to build nation-specific stovepipes. What they're best able to do is to help grow the ecosystem of expertise, research and development expertise within each of the countries. Every country needs to have this, right? Which why it makes perfect sense for all of these countries to be thinking about this, and to foster innovation, right? We have lots and lots of challenges with AI, not just on the application side, but on the R&D side of making it better, right? It is still the case that all of our AI systems are extremely fragile. It is still the case that adaptation to new environments is a horribly hard problem. It is still the case that we need huge amounts of data to build AI systems. And that is generally not available to all but the largest players in industry. And so there's huge research challenges to be solved that makes sense for everybody to be investing in. So the way I think of it is it's better for everybody if we all pool funds and make these kinds of things practical.
Thanks.
I don't have much to add. I think ultimately this stuff all becomes commoditized, and data, at least with today's paradigms, data is going to be what makes the difference.
I think we're going to be able to take some audience questions. So, yeah, Evgeny.
Yeah, just to follow on what Jeff just said and what Zach said at the beginning on the training is everything. And I think when Kurt showed his slides, I think one thing was obvious, but it resonated to me big time, that the training data sets that people use today, like especially in academia, very different of the real world type of data sets. So we've been talking a lot about democratizing tools and open source software type of thing, but what about data? Who owns the data, and and how we can use the data again for the AI for good type of thing?
Yeah, but I'm going to be a little controversial here. I actually think the focus on open data sets in research is hurting us. I think that industry needs the ability to really easily and flexibly have tooling to capture their own data for their real users, right? Their customers, their environment, and make that really easy and quick. And maybe some transparent sharing of training without exposing all of your data. How can we share it as an industry? In the automotive industry, for example, how can we pool our data, let you train a model on that without actually sharing the data sets themselves? So I think this focus on just academic open data sets is kind of hurting us because everybody's training on the same thing.
Yeah, it's really an example of the old joke of the drunk who's looking for his keys under the streetlight. And somebody asks him, well, why are you looking for did you lose your keys under the streetlight? No, but this is the only place where there's light. And really, it is the case that people define their research programs around the data which is available. And it's so bass-backwards that we have to go figure out ways to make data collection much more accessible, because data is really the thing that makes tinyML different from tiny embedded software. And so if it's going to have any impact, it's going to have impact because we got new interesting data.
So I just want to clarify that. And Chris, did you just call me a drunk?
No, but I know you lost your keys.
So let's just work backwards. To get a paper accepted in many conferences, maybe not ICML, you need a results table.
Yeah.
You need a results table that the committee members can identify, oh, this is better because in this standard benchmarks, they show some improvement, right, presuming that there's not smoke and mirrors behind that. And so we're in academics, and I think in general in the published research community, we're very much driven by data sets. That's just going to be a given. So I think the notion like, well, kind of a shame, I agree that it's a shame that for years we vectored off on data sets that say have 122 different dog types as an integral part of showing accuracy, such as ImageNet, which is very much at the core of a lot of computer vision research. So I'm a little worried that I heard up there the industry people go, yeah, it's like, oh, that's silly that they're.
Well,
those
are benchmarks,
yeah,
right? And benchmarks play a very positive role until a given benchmark outgrows its usefulness.
Yes, and so constructively, I'm asking industry types like Pete here. I was very happy to see the data set that they did, and I was a little disappointed that it's basically a subset of COCO. Something tells me that Google has better data than a subset of COCO that they could share with us, right? So we really do. So I think all published researchers really do need your help on data sets, which are closer. This will help us better solve the problems that you're facing in industry.
Right.
Hello. So regarding data sets, in Europe, there's this law that prevents you to acquire pictures of people to train your neural networks to improve safety, right, in cars, pedestrian detections, or all these kind of things. So actually, the governments are impeding your ability to gather these data sets because of privacy issues. And privacy issues are important, but there should be a middle ground that you can collect data as long as you can prove that you store it safely and just use it for training models. And I think that's where government initiatives can really help the AI take flight.
Yeah, it's certainly an area the Chinese have been at the other end of the spectrum in collecting the data and then giving it to everybody.
Maybe related to the same subject, in the US, I think there is a tremendous amount of medical data, images and so on, that is not in the hand of the companies, actually in the hand of the government or government-related agencies or hospitals, that if the issue of how to safely or privately handle them, they could be enormous use for this progress in machine learning, basically.
Yeah, right. We've made an interesting segue, I think an important segue from sort of tools ecosystem to data ecosystem. Back over here.
I would go again on the tools and ecosystem. So for industrial IoT, what kind of tools and ecosystem do you think can be standardized? Like for a big boiler versus a small motor, there are different kind of sensors, but beyond that, data logging and then maybe learning on it and then deployment. What kind of tools and infrastructures do you propose for it?
Yeah, this is something that's been bothering me a lot lately. I think we've outgrown CSV. Sorry, guys. I think we need to go towards some standardized labeled training data collection formats that can be applied by tinyML devices. You got to think beyond just what a server can store and process, but what can we very easily construct within a microcontroller and then send over a Bluetooth interface? Because I do think wireless is one of our huge limitations and opportunities for tinyML. So we have to deal with that. That training data has to be secure, signed, trusted. So we need a chain of trust through your chain of who has touched this training data? Where did it come from? Who's manipulated it in between? I think we're probably seeing a lot of errors in the industry due to just CSVs being corrupted as people work with them. Who made that change? When did it happen? The web industry has dealt with these kind of problems for a long time. So I do think we have tools from the IETF, for example, constrained web tokens give us a model, JSON model to do this kind of thing. So standards in these are going to be important going forward. I'd say the same as with feature extraction. I see tons of different approaches to feature extraction. It confuses the heck out of embedded people working with sensors. Just tell us what the feature extractions standard is for audio, for example, and we'll implement it and put it in every chip. But we have to know what that's going to be in order to do that. And so standardization on some default approaches to some of this would help.
Yeah, though it's not really different from them saying, just tell us what the network is and we'll put that in.
Yeah, that would be nice too. Yeah.
Can't you just agree on all the coefficients and then we're done? So one of the useful ways to get at this ecosystem question is to not make it very abstract, but very practical. You know, in your direct experience, tell me, if you can, about one instance where the ecosystem drove you crazy. There was something missing, something really kind of hard, something, or maybe it was easy, it just was missing.
I think you're asking us to bitch.
Yeah,
I think you're asking us to bitch about the.
Yeah, you got 4 minutes to bitch.
4 minutes to bitch. Okay. Well, maybe I can start. So
You
I
have one
told
in the
you.
third minutes.
Oh, okay. Well, I told you that standards and interoperability were so important, and I had such optimistic views that we could do that, and that would enable all sorts of third-party collaboration, and sort of asynchronous collaboration, non-explicit collaboration, and so on. It's all true, except that the ecosystem is moving very, very quickly. And one of the things that has happened is that, there are various parts of it that are sort of asynchronously broken at different times. One of which is Onyx. So, if you have looked at any of the model interchange formats and trying to actually use them for anything real, you realize very quickly that they are broken in 100 different ways. And the interoperability and the subset of models that are actually supported are somewhat limited and always far behind what the frameworks can actually support in terms of actual coding. Now, this is always going to be somewhat true because the frameworks don't support exactly the same things. And so it's sort of the lowest common denominator is the interchange format, right? And therefore, all sorts of issues arise from that. But it is less, it is even further behind than that. And at some point, that actually has to get fixed because a lot of the third-party opportunities that we've been talking about are broken because of it.
I would just echo what we already had in discussion. I mean, the most frustrating thing to me is data. Zach, I agree with what you said. The existing data sets are not sufficient, and so now we need to kind of go in a proprietary way and collect the right data for the right environments. And that's the big missing ingredient, I think, to making everything work. I think that the intermediary connection between solution and between solutions and need, is also out there. But we're already working on kind of, there's a ton of people kind of working on that already. Where they're figuring out how to make those connections today, and maybe some of the people in this room can help with that as well. But the biggest thing is the data problem.
So I think we have an even bigger problem before any of this becomes a problem, and that's that people don't know this is possible. I just did a test over the last few weeks, talked to all of the people I know in the industry. What do you think about applying machine learning to your microcontrollers, right? Your embedded systems? They're like, what, that's possible? I didn't even know that. And then the ideas start to come. And I think if I could give everyone, one takeaway from this whole summit is go back and evangelize that this is possible, right? This is real. It's real on today's MCUs. You don't need to wait for a magic accelerator to run really useful neural networks, albeit maybe small ones. That's okay. And I think that's a first step. You get that awareness. And I went through the entire IoT cycle, and I can tell you that new technologies take about a decade. And I don't know when you started working on tinyML. It's maybe been like 3-4 years that really work started on tinyML. So, we've got 6-7 years left to go before, and I want to depress you, but before, right, this is really everywhere. And a lot of it's just the rate of change that humans can take when it comes to technology, learning about new things. So the faster we get the word out there, the faster that'll happen.
Yeah. I think that's a good point to end on. So let's thank the panelists.